Hello, we're going to continue our review by looking over different reaction types and predicting products. There are 5 different reaction types that you need to know. And the first one is A plus B yields AB, where you have 2 small compounds or elements that join together to form one large compound. This is called synthesis or combination. Reaction number 2 is just the opposite. This is where one compound falls apart into 2 pieces. You have compound AB decomposing into A plus B. This is called decomposition. The third kind is when you have a single replacement. You have an element that is joining together with a compound. And what happens is that the element, usually a metal, will remove the other metal from the compound. So that metal B stands alone on the product side, and the new compound is AC. This is called single replacement. And single replacement is different in that you have to use something called the activity series found on the back side of your ChemHelper to determine whether this can go to completion. Basically, in order for this reaction to occur, metal A has to be higher on the list than metal B. If metal A is lower on the list than metal B, you won't get any products at all. Instead, you'll get no reaction. And that's exactly what you would have to write in the product side if metal A is lower on the list than metal B. Equation number 4 is called a double replacement. We have 2 compounds, AB plus CD. And what happens is that the metals that are in the compounds are going to switch places. And in doing so, we get 2 new compounds, AD plus CB. Now in double replacement reactions, we can sometimes get a precipitate or a solid that comes out of solution. In order to determine which product, now it's which product, so it's only the things that are on the right-hand side of the arrow. You need to use the table, the solubility table, on the back of your ChemHelper to determine which of these products is the solid. So we went over this in class today and we did a lab. And basically you have to find element A on the left-hand side of the table and the anion D along the top. And where they meet in the grid is a letter. If the letter is S, that means that it's soluble, which means that it is not a precipitate. But if where they meet is the letter I, that means that the compound is insoluble and it is a precipitate. So you want to look for the I's. The I's are the precipitate. The I's are the solids that come out of the solution. The last is called a combustion reaction. In a combustion reaction, we have a new term called a hydrocarbon being added or burned in the presence of oxygen. And the 2 products are always carbon dioxide and water. A hydrocarbon is a compound that's made of C's and H's and sometimes O's. So methane, which is CH4, is a hydrocarbon, or C2H4 is also an example of a hydrocarbon. Or we have glucose, C6H12 O6 also is a hydrocarbon. So whenever you see a hydrocarbon that's being added to oxygen and you have the products carbon dioxide and water, that means that you have a combustion reaction. So what I wanted to do next is to give you some examples on how to determine what kind of an equation we've got just by using these general forms of A plus B equals yields AB or so on and so forth. So let's say that I have the formula HCl, hydrochloric acid, plus zinc yields zinc chloride plus hydrogen. Well, the first thing I'm going to do is assign a letter to each element. So hydrogen is going to be A, chlorine is going to be B, and zinc is going to be C. And then over on this side, I have C, B, plus A. Now, if I take a look at this, I don't have any general form that is AB plus C. But what I do have is something that's very similar. Look at our single replacement reactions. We have A plus BC, so that's pretty close. That would render my example a single replacement reaction. So that's one way that you would be able to tell. What about this one? I have methane plus oxygen yields carbon dioxide plus water. And as I look at this, I see that I have to balance out my equation. There we go. All right, so let's take a look at this and see if we can't figure out what kind of reaction we have. Well, I notice right away that I have carbon dioxide and water in the products. So right away, I have an inkling of what this could be. But I need to investigate further. Let's take a look at what we have on the reactant side. I have oxygen mixing with a compound CH4. And this compound CH4 only has carbon and hydrogen in it. That means that this is a hydrocarbon. Well, if I look at all of my different reactions, I see that the only kind that has a hydrocarbon plus oxygen with carbon dioxide and water as the products would be a combustion reaction. So this is an example of a combustion reaction. So here I'm going to erase some of this so that we can stay on the same page. Let's say that I have a reaction of magnesium chloride plus sodium hydroxide. That's going to give us sodium chloride plus magnesium hydroxide. I just have to do a little bit of balancing here. Okay, and I'm good. So to figure out what type of reaction we have, I'm going to put a letter above each element, but also above each polyatomic ion. Remember that the polyatomic ions are counted as single things, single entities. So we're not going to break them apart. So here my magnesium will be letter A, chloride will be B, sodium is C, and hydroxide is D. Well, here what I've got is AB plus CD. And the only type of reaction that has A, B, and CD in the reactant side would be double replacement. And that's exactly the type of reaction this is double replacement. So I'm going to stop this video here. Stay tuned for the next video where I show you how to use the general forms of A and B and C and D to figure out what the products are given reactants. Thanks, guys.